Welcome to Making Connections in Proportional Reasoning, where we'll use a real-world problem to demonstrate how we can make connections in proportional reasoning on through patterning and linear relationships. During this problem, students will listen to a baby's heartbeat while at an ultrasound visit and then discuss what calculations might be useful to a doctor and the parents. Having the students estimate how many heartbeats per 10 seconds, per 30 seconds, and then finally how many heartbeats per 1 minute is a great way to incorporate equivalent fractions and also make the problem a little more relevant for the students before moving on. After students share out their estimates with the class, you can then reveal more information in regards to the problem. In this case, we give how many beats per 7.12 seconds for the students to work with. Students can then work collaboratively to determine how many heartbeats per 1 minute using any strategy they prefer. While many textbooks promote using a proportion or some similar strategy, there are many other connections that we can make with this same very basic problem. The first might be a table where students can use multiplicative properties such as doubling or tripling to get closer to the number of seconds or minutes required. While this may not be immediately obvious in our table, once we graph the data, we can see that this is a linear relationship starting from the origin. Helping our students make the connection that when we're dealing with ratios and rates, that we will get a linear relationship starting at the origin can definitely be useful as we move on into patterning and linear equations. Analyzing the table of values further, we can see that same rate of 18 beats per every 7.12 seconds, which can then be reduced to our rate of change, 2.5 beats per 1 second. This can also help students understand why equivalent fractions are important and what role they play as we move on to patterning and linear relationships. Continuing use of equivalent fractions with a denominator of 100, students can then start to generate an understanding of what a percentage is, especially as it relates to the context of this particular problem. Rather than ending the problem there, we can also bring this problem back as we enter patterning and linear relationships by identifying the initial value being 0 in this case, and our rate of change being 18 beats every 7.12 seconds. Students can then use this information to plug into a linear equation, such as y equals mx plus b, or b equals the initial value plus the rate of change times t. By substituting our values into the equation, we can see that the equation is b equals 0 plus 18 over 7.12 times t, or, after simplifying, b equals 2.5 times t. In this case, we can allow the students to see the final answer and then compare it to their own. As in many real-world situations, the theoretical and practical do not match, and this can engage students in a deep discussion as to why. Feel free to download the proportional reasoning template available on the website tapintoteenminds.com/MYCI for you to use some of the strategies outlined in this video, as well as some others not mentioned here. You can also look at the ministry resources, such as Paying Attention to Proportional Reasoning, where there are some great activities inside, as well as explanations as to where students struggle in proportional reasoning and what we can do about it. Look at the following question with your group. Use the template to try to solve the problem in a number of different ways.